Courbon'S method is the distribution of bridge loads across the number of girders. The position of the load makes a great impact on the distribution. Welcome to Bridge Engineering. The third example includes a simple span bridge of 20 meters length and reinforced by 4 girders spaced at 2 meters. This time, a uniformly distributed load is applied all throughout the length of the bridge at 1.5 meter to the right of the center line. We are to look for the maximum midspan moment in girder D using Courbon'S method. The bridge's longitudinal section shows its length of 20 meters. And the uniformly distributed load of 30 kilonewtons per meter is also observed. The bridge's cross-section shows the 4 girders A to D, spaced at 2 meters. Drawing the center line, girder A then is located at -3, girder B at -1, girder C is located at +1, and girder D at +3. Lastly, the line of uniformly distributed load is shown at 1.5 meters to the right of the center line. The first thing we can solve is the total midspan moment from the uniformly distributed load. For simply supported beams, the maximum moment at midspan is computed as WL squared upon 8. That is, then, 30 kilonewton per meter times the square of 20 meters all over 8. This is 1,500 kilonewton meter. Again, this moment is the total midspan moment for the whole bridge, so we have to distribute these across the girders. Next is the load distribution. We use Courbon'S formula again, where the total load is W times L. That is 30 kilonewton per meter times 20 meters, which is 600 kilonewtons. N is 4 girders. The eccentricity is 1.5 meters. And the summation of the squares of distances is the square of -3 plus the square of -1. Then there is the square of +1 and the square of +3. This totals to 20 square meters. X of D is the distance of the girder from the center line, and that is 3 meters. Place all these into Courbon'S equation, making 600 kilonewtons over 4 multiplied by 1 plus 6 times 1.5 meters by 3 meters divided by 20 square meters. That is 352.5 kilonewtons. With this reaction known, take the distribution factor to know how much girder D is carrying of the total load. The distribution factor is then 352.5 over 600, giving 0.5875. This means 58.75% of the total load is carried by girder D. Since we already figured out how much girder D carries, we can then solve for the moment. The moment is the distribution factor multiplied by the total moment. This is 58.75% of 1500 kilonewton meter, and the result is 881.25 kilonewton meter. For your practice, use a similar example, with a little tweak of the location of the uniformly distributed load at ½ meter to the right of the center line. If done correctly, the maximum midspan moment of girder D is 544 kilonewton meter. Good luck!